A standard fair cubical die is to be rolled 5 times and the number of 6s obtained is to be noted. Calculate the probability of each possible outcome and hence deduce that the binomial distribution is linked to the binomial theorem. So here we can see that n is equal to 5, and we're looking at the number of 6s when we roll a standard fair cubical die. So the probability of success is going to be 1/6. We'll call the getting a 6 a success, and therefore the probability of failure, not getting a 6, is 5/6. We could write this if we say that x is the number of 6s we get. So we could write x follows a binomial with 5 trials and probability of success 1/6. If we think about it, we could get no 6s, 1 6, 2 6s, 3 6s, 4 6s, or have all 5 6s. So those are the individual values of x, in other words, the small x. Okay, let's look at it. So if we have the probability of x being equal to 0, that means that all 5 rolls result in a non-6. So that is 5/6 times 5/6 times 5/6 times 5/6 times 5/6, or if you like, 5/6 to the power 5, and that would be 3125 over 7776. What about the probability of x being 1? Well, that means that we would get 4 non-6s, like so, and 1/6. But of course that 6 could occur in any of the 5 rolls. And so what we could do is say, well, times that by 5, choose 1, because we've got 5 slots, 5 rolls, and we just need to choose 1 to be the one that gives us a 6. And if you calculate that, that also gives 3125 over 7776. What about the probability of x being 2? Well, we're going to need 5/6 times 5/6 times 5/6 for the non-6s, and then we'll have 2 of those. And there are 5 possible positions to choose the 2 6s to go in. And if we calculate that, we get 1250 over 7776. Of course, we can make that 5/6 cubed and a 1/6 squared, should we wish. I'm just not going to do it during this example. Probability of x is 3 would then be 5/6 times 5/6 times 1/6 times 1/6 times 1/6. And in the same way we did before, we've got to choose 3 slots for our 6s. And if we do that, that's 250 over 7776. Probability of x is 4. We only then get 1 non-6, and all the rest are 6s. And 5 choose 4. And if we do that, we get 25 over 7776. And finally, x is 5. All of them are 6s, so that's just going to be, I'll just do that, a 1/6 to the 5. And that is 1 over 7776. Now you can check all of those do add up to 1. But notice it's the distribution you'd get if you did 5/6 add 1/6 to the power 5 and expanded it using the binomial theorem. And that's why the two things are linked.